Let's talk today about compound beam. Usually I'm giving this type of problems in my midterm number 4. So for static students, we need to find the reactions at supports and to find the internal forces at some point. And for strength of material students, they need to draw moment in shear diagrams and to find the state of stress. So I picked one example from statics book. It is compound beam, which is fixed supported at point A. We have beam which is connected at B and supported by a roller at point C. We have an external load of 500 pounds per feet, and we have 3 unknowns at fixed support, 2 unknowns at pin or joint at point B, and 1 unknown at point C, which will be a vertical reaction for a roller. So 6 unknowns, that means since that we have only 3 equations of equilibrium, we need to split the system into 2. And the easiest way how to solve this is to split firstly from point B to point C. And in this case, we will have a simply supported beam subjected to uniformly distributed load. Instead of uniformly distributed load 500 pounds per feet, we can use only point load Q, which will be 500 times 6, which is a length. And we will have 2 unknowns at B and at point B, B and HB, and 1 unknown at point C. So using the equations of equilibrium, HB is equal to 0 because we don't have any external loads in X direction. At sum of forces in Y direction to be equal to 0, we have B plus C is equal to 3,000 pounds. And we can use a moment at point C or moment at point B. It depends on whichever side you like to do. Imagine that we have at point B. That means we have reaction at point C, C times 6 feet minus Q, which is 3,000 pounds times 3 feet. So that will give me the value for B and C to be 1,500 pounds. When we are done with the section BC, we are going at the section AB, which is in this case cantilever beam. So we have 3 unknowns at point A, so vertical force A, age A, and we will have a moment. And now again we will have instead of uniformly distributed load, we have 1 point load, which will be 500 times 3. That means we have a Q of 1,500 pounds. And we determined the reaction at point B to be 1,500 pounds. Now we are applying that reaction as external load, but this reaction at point B has to change the sign. So again, we are using sum of forces in X direction to be equal to 0. So that means AJ is equal to 0. Then we have sum of forces in Y direction to be equal to 0. That means A minus Q, which is 1,500, minus B, which is 1,500, is equal to 0. That will give me a value for A to be 3,000 pounds. And sum of all moments has to be equal to 0, which means the moment to point A from a distributed load will be 1,500 times 1.5. Then from reaction at point B, which is 1,500 times 3, and we will have minus MA to be equal to 0. So using the third equation, we will determine that MA is 6,750. So internal forces for us, important points 1, 2, and 3. At point 1, our shear force will be positive if it is going along the Y direction of coordinate system. So we have reaction at point A, which is 3,000 pounds, and that is our shear force at point A. Then we have a moment which is counterclockwise, and in order to find the positive value of moment, we said that moment here has to be clockwise. So moment here is minus 6,750 pounds-feet. Normal force is equal to 0. Point 2, moment at point 2 is 0. Moment at point 3 is also 0, but the shear at point 2 will be reaction at point B, and that means 1,500 pounds positive. At point C, we will have reaction at point C. Again, the reaction is along the y direction axis, but shear at this point is positive if it is going down. So that means we will have negative shear, which is 1,500 pounds. So how our diagrams looks like. At point 1, we have 6,750 pounds-feet. Then we have a 0, so we are connecting the two. And we have parabolic part, which will come from distributed load. And we said that parabolic part is QL square over 8, which means 500 times 3 on square over 8. So this is our moment diagram from point A to point B. At point or in a place B to C, we will have only parabolic part, again QL square over 8. So that means 500 times 6 on square over 8. Regarding to shear, at point A, we have 3,000. Then we said at point C, we have minus 1,500. At point B, we have positive 1,500. So we are connecting the two. And again, we are connecting 3,000 and 1,500 for a shear, since that it is not straight line, but we are connecting the two like this, and you will get a shear forces. In strength, the addition is you will have some cross section. You need to determine the centroid at moment of inertia, and state of stress will be due to bending. You will have sigma is equal m times c over y, and your transverse stress will be v times q over I times t. So this is the part which I wanted to cover today. You have an exam. I wish you all luck, and if you have any questions, press a comment below. Thank you.